Hi, welcome to another PlayBASIC live video. Today I thought we might have a quick look over a demo that was posted by Steve on the forum, which is an update of one of the ones that comes with the help files. It's one of those things that I'd kind of forgotten about, and when the help files were generally written probably about 10 years ago now, so it's a long time ago. One of the limitations of PlayBASIC is that because it's purely two-dimensional, that when you have things like polygon rendering and in particular texture mapping, is they are linear, and that means that if you try and use them to represent three-dimensional objects, you lose perspective. 3D video cards have perspective correction, which is quite expensive to do. I mean, these days really we probably could add a software version of that into it, but the video cards also have a secondary feature, which is Z buffering, per pixel Z buffering I should say, which really is just a second version of the picture that's being rendered, the scene that's being rendered, and all it contains is depths, the depth of each pixel. So when a new polygon's been rendered, the renderer first it computes where that pixel is going to be. It computes its Z value. It then checks the current Z value at that location on the screen. If the new pixel is in front of that old or the existing Z value, it gets rendered. And that means that polygons can intersect each other and all kinds of those sort of cool things that are actually hard to do when you don't have that. In PB we don't. The polygon support was actually made for doing kind of trivial things in two-dimensional scenes where you would use polygons rather than having to use sprites. That was the original idea. You've probably seen old 2D games that have pseudo 3D elements in them. I just can't think of one off the top of my head. Anyway, so Steve's been trying to write a little 3D engine, and you might have noticed there's a few 3D engines that have kind of been written in PB over the years. And they all have the same limitation. Polygons can't intersect each other, and they're not prospectively correct, which gives you how would you put it? It gives you a fairly rough looking image, noisy looking image generally. Those who played a lot of PlayStation 1 games would be familiar with that, because the PS1 didn't have perspective correction for its texture mapping either. And from memory, it didn't have Z buffering either. So the guys the people who wrote most games really were coming up with some pretty ingenious ways to get around those issues. The perspective correction problem is generally overcome by subdividing the face we want to texture map, and we could take the polygon, break it up. I mean, he's got a picture kind of showing. It's actually showing the texture, and the lines are closer to perspectively correct. We'll have a look at the demo in a second actually. So the demo's on here for download, and then there is the one that comes in the example pack too. If you don't have the example pack, you head over to PlayBASIC, and under the PB Learning Edition download, which comes with the example pack in it, so you don't really need this if you've already got that, you can grab a new copy of the example packs down here. I've just done that before because I've just copied my work folder, my PlayBASIC folder, from one system to another, but didn't actually copy the projects with it. So I want to come back and look at that in a second. Alright, so we'll head over to PlayBASIC. I've already downloaded the example and had a look at it before. I am using a different version of PB, so hopefully it will compile and run straight away. I might set the frame rate a bit slower so we don't set down to about as low as 20 to help with the capturing software. And we'll leave that open screen there. Let's pop to the back there. Okay, so in this demo here, it's showing us, I'm not quite sure what the keys are now. It's showing us, okay, this is the A-Fine mode. I think in the original demo I provided, that's the layout of the pixels that are being, sorry, the layout of the polygons that are being subdivided, which is not a very efficient way of doing this rectangle. It really should just be a grid, but you know, let's see some other ones. So if we just cut it in two triangles, we get a kind of warped looking face. We can rotate the thing around. The warping is much less noticeable when all of the Z coordinates are closer to each other, because that's where perspective has the least amount of impact on the image. When it's much more acute to the viewer, that's when we really notice the warping. So we'll try some other modes. It's a better looking mode, isn't it? Still a bit warpy, but generally better. And Steve's last version here. Obviously you can see now I've got approximations. I've cut this whole surface down into texture, or sort of polygons that are much closer to the size of each other. Which I think is a better idea. So we get this perspective is correct at these points, but it's not when it's mapped across this space. So that the closer you get to the object, the worse the effect is, the warping will be. Can we zoom out of this one? Oh, there we go. You can turn those points off there. So the further you get away from the object, the impact of it is much less noticeable, because the area that's being represented is being rendered in a linear fashion. The less impact the perspective has on it. Pretty cool though. Very cool. Cool work there, Steve. Back to the first demo. It does rotate around all. Just trying to work out the keys. No, it's down the bottom there, it says that. There you go. I to change texture, so we can just go back to 404, but get a pretty good looking approximation of perspective texture mapping. Very cool. Okay. Just break out of that one there. Hopefully that captured all right. Have to bear with me here. I'll try and find it. I think it's in my documents. Back to this PC. Documents. When PB installs the Learning Edition, by the way, the installer will place these files in your My Documents folder. I've noticed on a couple of different systems, different versions of Windows, they've actually gone to somewhere else. I can't think of where it was now, which kind of makes it a bit frustrating for new users. This is an old example pack. The examples here are probably, you know, at least 7 or 8 years old. In many cases older than that, and some possibly a little bit newer. I think in demos here we might have to adjust some of these to make them run. The 3D terrain. Oh, hang on, 3D texture cube. Let's give that a go. I think this is the version that I wrote, is it? Apparently so. So it was written back in 2004, quite a while ago now. Just check what screen mode that's going to run in. I want to run it in a window because I don't actually want, I don't think this capture software can capture full screen exclusive. Yeah, this is the same demo. Okay, subdivide linear mapper. You can see it warping a bit. What's the keys? I don't know. Oh, pure linear. So the warping's much more noticeable there. Oh yeah, it's got the same thing there, showing it there. I'm not quite sure why I didn't use a grid now. Should have. Would have been a better effect. Anyway, so that's one of the examples in the help files. 3D terrain, I think, is the one I was going to show. I think this compiles and runs, but I haven't actually bothered to check. Title. Okay, it's going to ask us about screen mode, and we're going to set that up. I'll just set that to windowed mode. See if it compiles it all. Ah, I'm using a much more modern version of PB here than what these versions were written for, and it doesn't allow you to do queries of instructions like that when they may be. Old versions of PB have a bunch of code in them where it kind of ignores that. There's probably a bunch of those in these loops here. So there we go. So we might get a few runtime errors where it's not happy with the way this old code is laid out. It's interesting. Okay, let's do a bit of debugging on that. Let's see why, or whereabouts we're getting to before it's actually hanging. Well, it seems to be hanging at least anyway. So what we'll do is we'll put in a little comment, OK here. We'll put break after that. There shouldn't be anything up there that's causing a problem, but we'll find out now. So in menu we are OK there. We'll just shift that down lower. Set up all our buttons. We'll run it in debug mode. Turn caps lock off. How are we going? I don't know why the capturing makes it do this. It really is frustrating. So there's something that happens before this point in the code that it's really not happy about. Cancel. So easy way of working out what's going on is just let's move our OK message back to here. Try running it again. Yeah, program is halted correctly there. Pull that across there so I can get a bit more screen real estate made up of that. I think our problem is going to be in this create button. So we're kind of doing like a bullet test debug here. We're sort of just not reading the code, we're just looking at it going, okay, did it crash there or not? It's okay at this point. So looks like our likely candidate for crashing is inside this PBGUI test button. Let's go have a look at that function, find declaration. Oh, we do have a possible thing there. We'll check out this new button. Okay, if this equals, what's actually happening there is that the app's running into a, the first time that's called, it would never actually, oh sorry, if this is not equal to false, that should be okay. Should return our handle. Exit do. Handle is here. Creating a new button. But we didn't initialize that structure, so what I might do is just make sure that that's initialized correctly in here. You'll notice that there's no, I haven't bothered to check that the handle coming back, which is really just the array index of this typed array, is actually valid. So we might do that up there as well. We might crash further down. Just make sure it's bigger than -1. If it is, we'll allocate a structure. We'll allocate the GUI button structure, whatever that happens to be, I don't know what it is. And then we'll fill it in and we should be okay. Let's try that. Oh, for goodness sake. Okay, we're saying we're not responding, so it didn't like that. So what we need to know now, is it crashing when it initializes the structure, or is it crashing when we call this new button function? I think it's probably that new button instruction. So we'll put a little message here to the console. Structure or whatever. And then we'll go up to here. We'll find this. Exit to. I must actually make a scope name there. That would be very handy. Okay, so we'll get a debug message there. We are asking the array how many elements are in it. There is an assumption there, isn't there? There's the assumption that elements is actually bigger than 0. Now, I assume that's going to be the case, but I just want to make sure that's actually going to do that. Otherwise, that could be a problem. Oh, we could just exit do there. Exit do. Might just put a bit of debug stuff in there just to make sure. So I'll print out elements. Newer versions really are a lot fussier about things in general. Yeah, that's pretty much superfluous there at all. Handle equals left. Yeah, we'll just put it in. So when we first call this, we should be getting a handle of, or potentially 0, isn't it? Which seems a little bit odd to return a 0 as. Go back to here. So we might put a break in there. And we might put a break here. Okay, to exit. It's just for us to, so we can see if we're actually executing this block here. Oh, sorry. We want to print there. Every time you try and capture this, it just does nonsense stuff. No, I think that's. I think our problem there is. Yeah. Okay, so when we get to the library we're using buttons. Fall through, the buttons array is initialized to 1 up front. Our palette is predefined. Drawing the buttons. There's a potential problem there too, isn't there? When we check, we want to make sure that that's actually has something allocated there, not just because we might pass in a null. Same as here, find button, if this thing here, okay. So what you tend to find with old examples and newer versions of PB is there's bits and pieces that it just doesn't like them. No, there's another one there actually. We'll just assume that we'll make that slight change. We'll just check if the type structure exists, and then we'll just assume that it's actually accurate. They're just shortcut structures there. Oh, that won't equal true. When we query the array like this, by the way, we're returning the handle, which is just kind of it's the special number that the array, the structure of the array is hidden behind. But PB can query those things up front to make sure that you're accessing something that exists. I think in this case here, what's happening is we're getting something slipping through that defense. The newer runtime has some paring back of that stuff actually, and that's how it's kind of possible. So older ones are kind of hold your hand a little bit more, and newer versions, yeah, they're not really into it. Oh, it says that one's handle, isn't it? I don't think those things I'm just changing there are actually the problem, but I can see that if we get beyond where our current problem is, we will have issues with those. Depending on how the rest of the code uses these functions. just do a quick save of that. Now, back to menu, let's have a check of this find declaration. So we're not actually getting out of here without it dying. This is a key point. We'll put a break in here just to make sure that we are actually at this point. So we should see this message here printed in the debug console, and then the number of elements the array has, and so forth. We'll give it a go. Oh, that's... I can see the problem down there. That's actually bogus. Console. We have no elements. That's interesting. Let's check variables. Now, in main, that button array is defined. P button up here. And that's true, there are no allocated types, but it does have a size of 8. Get array elements, that's interesting. Why is it doing that? I don't think it likes the full type handle here. Or I made a typo. Gotta be careful. It's not the first time I've made a typo. It won't be the last for that matter. Let's check it out this time. So console, we do have one element in the array at least. Go back down here to structure, we can look inside what's in it. Very good. Now, this is broken for this very reason. We are looking for something in this array that's empty, so we actually want to compare this handle to 0. If we find a type in the array that has no handle, so it currently has no structure allocated at that position, the next line of code is going to crash. Just up here we're saying you found an empty cell, but here we're saying, okay, the cell has no data allocated at it, but I want to read from the non-existent data, so it will just die. We don't need that. Bit of a save. F7 to run it again. Looks like we've got through okay. We'll just check our structure. Here. We'll run to get to the next breakpoint. Program halted. Right, so we actually got out of the structure okay. We'll just change structures. And we do see in our PBGUI buttons at index 0. I'm not quite sure why it allows that, but it does. A whole bunch of stuff about it. So I think that's actually fixed that problem. Let's just try running it normally. See what else is broken. Oh, I've got that far. Pick a screen mode. Oh, it's limiting the mouse. I didn't want that to happen. So I think the demo's running. Mouse look 50, okay. I don't want it to limit the mouse because we're trying to capture the screen at the same time, and it creates a bit of a problem for us. Okay, let's try it, see how we go. Come to the front. Come to the front. There we go, we are running. It's a lot of messing around for not much to look at, isn't it? Well. That's better. I don't know who, I think this might be a Facet picture, which is a kind of famous demo artist. Great picture. There's a bit of a problem with the clipper there, isn't there? But there you go. A lot of messing around to get that running in this version of PB. But I've got a basic objects running a basic terrain running. And it's just a height map. It's just a mesh that's where a 2D array is probably a better way of putting it. So it's a 2D array, and the heights at each point across that grid are variable, and the polygons are made up by connecting the X and Z, which are at uniform points apart. If that makes any sense. Yeah. I'll have a quick pick through the code while we're here. So this is the main loop. Let's have a look at build terrain. I've got a bit of randomness for our size. A bit of we're creating the height map, which is just a two-dimensional array, I would say. We're applying an average to it to try and smooth out. If you just apply randomness without smoothing it, you get a very rough and jagged array. So we're actually defining a 2D array of heights, and then we're actually creating a terrain from that height. So this is just a PB function. Let's have a look inside it. So we've got a bit of a library for creating our terrains here. We've got a get free terrain, which I suspect allocates the object, and so when it returns the index, it'll always return a true the index of a position in the terrain array that actually is allocated. So then we can just fill it in the way we want. I think this example uses the, just have a look actually, Vertex Objects library, which is another really old library. These are for doing, you can define kind of an object, a 3D object, and these things have a position, a orientation, a scale in three-dimensional space, and each object has a set of vertices. So you would call create vertex object, and it just gives it a position. You can set its rotation mode. Obviously there's a couple of modes. I've forgotten what they are now off the top of my head, but you can position the object in space, get its position, apply rotations to it. And what actually happens is when you use these in this kind of handles the structures yourself, and you can call the rotate commands, which are elsewhere. Not making much sense, I know. It's really just a bit of a quick sort of go over this whole thing. So in the terrain library here, we've got our terrains, this structure. We're going to have multiple terrains by the looks of things. We create a terrain, we're just setting up this array here. Go back to here, we'll look at, so this thing here was creating our terrain structure in the terrain library. And we're calling this function here to initialize the terrain vertex. So this probably does the real mesh generation for what's going on. Yeah, it does. There's a fair bit of code in this part here. Not massive amount, but a fair bit. So we're passing in the index of our terrain and our height map, because we need those to set up our polygons. getting at the width and height of this array, getting our texture. We're checking to see if there's any vertice buffer that already exists for the terrain. If there is, delete it. Is there a rotated vertice buffer? If there is, delete it. Computing the number of verts we need for this terrain, allocating some just normal PV banks to store this stuff, creating a dummy vertex object. We're rotating it to 0, 0, 0, which should be by default anyway. Storing its vertex object here, and we're storing its vertex buffer here, the number of verts, and we're going through and setting up the vertices in that buffer. So this bank here ends up with all the vertices of the heights in it, ready to rock for the terrain. That's why we're setting the X, Y, and Z of every point on that terrain, and then later on, I would hazard a guess, we're making a mesh from it. There we go. So we've created our vertices from our array. I'm calling this function here to build the polygonal mesh that represents that's going to be rendered. Looks like standard setup here to me. Getting the width and height of our level, of the terrain basically. Oh, yeah. Sorry, just daydreaming a little bit. We're computing the size of each phase. We're allocating a bank, getting the pointer to that bank. There's probably a structure up here that actually pokes into. Let's look for it. That's the terrain structure. No, apparently not. Might just poke directly into memory. So we've allocated a bank which is going to hold the polygons for this terrain, remembering the start of the mesh for some reason. Getting the width and height. This is the UV coordinates of the entire space. So our texture is a certain width. This would be U1, V1 would be the upper left hand corner, U2 would be the upper right hand corner, U3, V3 would be the bottom right hand corner, and this would be the bottom left hand corner. So it goes like this. You've got this kind of up here, 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 here. Must support transparency as well. So yeah, we're getting some pretty ugly looking code where we're actually poking in a polygon structure. Each polygon has a number of vertex. In the terrain, they would be just triangles, so there would be 3 vertex per triangle. It's got a fill type and a texture, which is getting that from. Yeah, it's pretty full on. So we're filling out our UV coordinate at this point, giving it a colour which is not used in this demo, stepping forward through the structure, poking them in, dumping for each square on the height map grid, we need 2 triangles. That's why it's got a second triangle here as well. That builds our mesh. Ugly, but it does. So we're positioning the terrain at a point off the camera, away from the camera. Let's go back at the top. Yeah, that does the real work of the whole demo. I think here we're running through the, yeah we are, sorry, we're loading the texture and creating we might be cutting up the texture into smaller shapes actually. Oh, that's interesting. I think other versions of this demo don't do that, but let's look at this load terrain texture. No, it's just loading it straight in. It's got to prepare effects in there, so it's got a bit of work to do. Stuff here is setting up the PB camera, the 2D camera. You've got a clipping plane, which is used when you add triangles or just triangles or quads into the scene, and it will clip those on a far and near basis. So this would be the near point, so it's 50 units away from the camera. The other one is 15 away from the camera. So you get max Z depth of 1600 there, so anything that's beyond that point gets culled out of the scene initially. We have to make sure PB's scene buffer is big enough to hold all of these triangles that are going to be generated in it. It's a bit of a mouthful for it, to be honest. I was never intended to do this kind of stuff, but it's just one of those weird things. So our main loop is this. We've got our mouse look function, which we modified before. I was just letting us turn the camera around, do those kind of things. Got a move forward, move back type structure. So draw terrain to the camera. Let's have a look at that routine. We're using a couple of undocumented commands that have been around for a long time. This is probably why this would be why they've never been used. And they were kind of there as an experiment, really. Is it practical to do these kind of things in PB when it doesn't have perspective texture mapping, it doesn't have Z buffering? It kind of is, and it kind of isn't. You know, it's up to the individual as to what they're after to do. So we run through this command here. We're drawing one mesh to the camera, which we've defined elsewhere. So we check the terrain exists. Not the best way of doing it, as we've just known before. We should just check the structure exists and then assume that if there's a structure at this point, then it has to be a defined terrain. We get the center of the viewport for our 2D stuff, our 2D rendering. We get the object, which is the bank that the object is actually using. It's a bit of double Dutch there, sorry. The 3D object is using, the terrain object that is. Just a normal PB bank, but it's filled in with that structure that the vertex library expects. We get the vertice buffer locations, the number of vertices, and we pass these to this function here, which rotates a list of vertices to the camera, which is this thing we're passing in here. It's a particular structure. So the resulting vertices are projected, rotated for that viewer, whatever direction it's facing, or wherever it is. It doesn't seem to have any clipping here at all. So every triangle in that scene is getting passed through and being drawn. Now this part is doing the rotation, and down here we're grabbing the address of the mesh stuff, the number of faces that are in the mesh, the projection that we need, and passing it to translate to scene. This runs through our three-dimensional object and puts all the polygons drawn. It'll clip them, put them into the scene buffer for us to draw. So when we come back from this function here, when we hit draw camera, it's going to do all the Z buffering, all the per polygon Z buffer, so they'll all get sorted into order and drawn. The furthest polygons get drawn first and successively closer. So it's called Painter's algorithm. It's a very old method. It's not particularly pretty. Displaying some frames per second. Got a space key detection here, so if we hit space we can regenerate the terrain object. And a bit of a message about or display a message based on the time. I know that's probably a terrible overview of this piece of code. It's very complicated. This vertex objects library, this is actually one of those our source libs that are part of PB that we some of them are documented, some of them aren't. Depends on what version of PB you have. Look at the examples here. These are building command sets up here, and then down the bottom we have libraries. These are just include files. They do various different tasks for you, but there's more than this. You know, there's more. They're stored in a folder called slibs in your PlayBASIC installation. Go have a look at them. You might find some weird and wonderful stuff in there. They're undocumented, they're unsupported, so don't be surprised if something doesn't work. We just give them out. It's like, well, here you go, mess around with it all you want. The ones here we've obviously put a bit more effort into, but some of the other ones they're equally as fleshed out. Like there's a GUI library in there, but trying to explain that to people is very complicated. Probably got another couple of 100 commands to set up the controls and set up the control loop, and there are some examples around the place to show it being used. But you know, it's a hard one to get through, and it's not really something that we're going to add to the core language. I'd rather than actually build a very static GUI system in, I'd rather add support for the things that GUIs need, which is one of the reasons why we added things like call function, which in the original version of that GUI you couldn't do, but then we added that later on. There's newer versions where you can actually do callbacks to your own functions and makes it a lot more convenient for the user. But it's still an undocumented, unsupported thing. You're welcome to use it, but if you find something that's broken, then that's up to you. Anyway, so this has been a bit of a bust. Just have a look at what other things are in this scrolling cube screen. Okay. Oh, yeah. Just set that to 1. Oh, pull the speed down to 20 frames per second just to make sure it doesn't run. You never know with some of this stuff. Yeah, this doing it. Okay. Which you've probably seen already. Hopefully this stuff is even capturing. I mean, it often doesn't capture very well on this little all-in-one system, but that's just what I'm on today. I think this uses the rotate to camera functions to do the rotation, and then it's just using normal sprite rendering or to do the actual displaying of the scene. I'll have a quick look at it actually. Stuff here is just making some of the images that are drawn. Number of particles, whatever that is, would be the number of objects in the scene, obviously. Okay, yeah, there you go. Rotate vertex list. So the list is just a list of vertices, which are to have an X, Y, and Z component. and they're not documented, but from here you can kind of work out what's going on. So this would be the address of the unrotated vertices, and the 12 looks to me like it's the modulus, which is, or the pitch, which is the number of bytes between vertice 1 and vertice 2, and so forth. So they're all spaced out at the same point. The destination, we want the rotated coordinates to be put into this place at location 12. I've got a feeling that there is our position. We've got a depth there, and this is these ones here are our angle, our orientation of the object, and the number of particles, the number of points. So that should be okay. Let's try moving that across. See how that or if it has any effect on the scene. Yeah. See, it's the center of rotation now is way over here. Cool. Move it a bit further. And down a bit. 100. Yeah, almost completely gone. The kind of blur effect here is done with a blit image routine. It's just try and find that function call. There you go. Gee, I hope that's... Yeah, well, some of these ones here are actually been just straight in the... They're just done for you. Blit image alpha 50. So what it's doing is it's rather than clearing the screen, it's doing an alpha blend. We'll check which mode that is, or the ink mode. So 128, it's doing an alpha subtraction of whatever this input color is. This clear RGB color here we're passing in. So then the ink here, we don't really need to do that, to be honest, but that's just how this old code is working. And then we're doing a source blit image merge. There's a much more updated version of that. It's actually a library in here, blit image, and you can just include. But this obviously has this demo is obviously so old that it kind of predates that library being made. So it actually probably uses the very first version of it. A command like that is probably not in the documentation either. No, there's blit image in the documentation. No, there you go. Behind the scenes, blit image is really just a set of kind of optimized routines for doing large screen copies with MMX encoded routines. So you can do things like multiplying the pixels by colour to do tinting, or reducing the RGBs by a certain amount, that kind of stuff, or adding a colour to the image. There's a whole bunch of them there by the looks of things. Again, well worth a look at. 2006. So 12 years ago. It's 2018 when I'm doing this. Alright, that's enough me rambling on. I didn't mean for this to be very long, but it's turned out to be probably the longest thing I've ever made. Getting back to here, getting back to Steve's example. Happens sometimes, the idea. You can find Steve's example for the 3D Cube, the updated version on the forums. Just log in and it's down here in the first post. Just got some other discussions down lower about how we might attack the problem of subdividing the walls, which is really cool. And here I think I was talking about the simple 3D engine for PB, which is I think it's just an updated version of that terrain demo that includes support for objects and stuff like that. The version here actually has actually does have real object loading in it. It's still, not prospectively correct. You don't have Z buffering, but it's a bit of fun to mess around with, I must get around to building that and putting it up in the forums. I did find a new version of that lately, more recently. Okie doke. Thanks for listening to me waffle on. Sorry it's been such a long waffle on today. That's all for me. Thanks for listening, and I'll catch you some other time. Bye.